In this example, we have a triangle, and in this triangle, we have a set of parallel lines. Now, what these parallel lines are doing is they're going to cut this triangle. We actually have two triangles. If we wanted to look at it that way, we could draw these out. We would know anytime we have parallel lines, we have congruent angles. So I could draw these triangles separately, and we could be looking at triangle FGJ, and then we have our larger triangle, which also has angle F, but then we have side H and I. And because of those parallel lines, we would know that these angles corresponding would be congruent. So this angle would be congruent to this angle. And then we have corresponding angles on this side at G and H. So those angles would be congruent. So we have similar triangles by angle. But there's something else going on as well. And that is that these sides, FI and FH, are being cut proportionally. So another way we could solve this, it's a little bit of a shortcut. If this is my unknown that we are looking for, we could set up a proportion that 42 over 30 would be equal to our unknown here, segment FG, over 20, and solve it that way. So we could either use the entire triangles here and separate them out that way, but if we're looking for the sides that are being cut by the parallel lines, then we have this shortcut. If we were looking for these sides that are those parallel lines, we would have to separate it into these two triangles. But in this case, cross multiply, so we have 30 times our segment FG is equal to 42 times 20. Divide both sides by 30. Now we use our handy dandy calculator. So I'm going to have 42 times 20 divided by 30. And we find that segment FG is 28. In our next example, same idea. We little bit different scenario this time in our given information, and that we're given this entire segment XZ is 45. We're given this segment XY is 30. We are looking for WX, that's right here. We're given this as 12. So we have two different ways we could do this. We could use the entire triangle, like we just said in the last example, where they're being cut. And so we would have our triangles that are similar by angle. Or we could just subtract this right now and say, okay, well, I would know that segment ZY, if this entire thing is 45, then that means this piece is 15. And we could set it up, same sort of a shortcut as what we did with this last one. Again, I'm looking for this missing segment. So remember, there's lots of ways to set up these proportions. I could say 15 over 30 is equal to, I started here, went this way, 15 over 30 would be equal to 12 over our unknown here, that would be x. Now I can reduce this. Remember, 15 goes into itself once, into 30 twice. So that makes this much easier math. We can see here now x is going to be equal to 24.